Hi guys, from today I'll be starting a series in which I'll be solving the daily LeetCode problem and explain the solution to you. Okay, so let's start. Okay, so today's problem is longest common subsequence. Given two strings, text1 and text2, return the length of the longest common subsequence. If there is no common subsequence, return 0. A subsequence of a string is a new string generated from the original string with some characters deleted without changing the relative order. Okay. So for example, AC is the subsequence of ABCD. Okay. So the length of the strings is 10 is to power 3, which means we can do this in O of n squared time, and I think it's a standard DP question. If we can use 2D DP here. Yeah, so okay, so let's just create an array DP. So this DP array is the array which will store all the combinations of indexes. So what my intuition is that uh, this in this DP array, 2D DP will have two indexes, index I and j. DP of I comma j will specify the longest common subsequence up to that indexes in the both strings. Like if in string 1 we are at B and in string 2 we are at C, then DP of 1 comma 1 will store the maximum, the longest common subsequence up till index 1 comma 1. Okay, so I have created the 2D array DP. Now let's initialize it here. This will n will store the length of string 1 and m will store the length of string. Okay. Now I have to resize my DP array. So what I will do is equals to, so by doing this my DP array has increased its size to n comma m. Now um, now let's create a function. Let's name it solve. This function will return the this function will return the longest common subsequence up till the length I. So we have to pass the our indexes I and j, and here okay, So what we'll do is we'll start from 0 comma 0 on both strings, and then if the indexes are same, then we will just return 1 plus and increment both the indexes. But if the indexes are different, then we will return maximum of the next two possibilities. Like in one possibility we will increment I, and in other one we will increment j. And the final base case will be if, let's say, both of the indexes are out of index. So let's create two more variables. Let me create them globally. Len1 and len2. These will store the size of a DP array. Len equals to- okay. Now if I is greater than equals to n, or g is greater than equals to m, then we'll return 0. Otherwise, also we have to pass our strings. And I'll pass them by reference, which will save us some memory. Now we have two cases, right? So if the value at these indexes match, if x1 of I is equals to x2 of j, then we will just return. Also, we have to update DPI, so what we'll do is we will return DP of I j equals to 1 plus solve I plus 1 and j plus 1 x2. So what we have done here is that we have incremented the index of both the strings, right? And if that's not the case, the values at those indexes doesn't match, then we have to return um, dp of I and j equals to maximum of dp of I solve I plus 1 comma j x1 x2 comma solve I plus j plus 1. So what we have done here is if the value at those indexes doesn't match, then we will return maximum of these two cases. First we will increment the index of first array, and then we will increment the index of second array. Okay, so also yeah, we have forgotten, like if we have already uh, generated the answer to a particular case, then we will return the answer. So we will initialize it with minus. The DP array has been initialized with -1. So if DP of is not equals to -1, then we will simply return DP of I and j. Okay. here we will just call the function return solve 0, 0 our starting indexes and exponent x2. I guess this should work. Let's run it. Oh yeah, we haven't passed them. They should be len 1 and they should be len 2. Yep, it's working. Let's submit it. Right, got accepted. Okay, so in this solution, we have used a top-down approach by using memoization. We can um, like optimize it further by using bottom-up approach. Like we will build the answer from zero. Okay. Yeah. So what? Let's just instead of calling this function solve, what we'll do is let's just reset the code. We will create a array and just okay. So now we'll try to do bottom up approach. Okay. So we have to initialize first the zeroth row of DP. Okay, so um, we'll initialize for we have to go from bottom to up, right? So we'll build our array from down. Okay. So what is our DP of I comma j? If they match, then it's well good. But if they doesn't, then we'll just take the previous maximum, right? Yeah. So what we'll do is we have two loops for it. I equals to 0, I must be less than n, I plus plus, and so our outer loop will traverse the first string and inner loop will traverse the second string. Okay, so um, yeah, so if we are traversing the other string, So first, I think we should initialize our ith string, or let's just write the conditions. If uh, x1 of I is equals to x2 of j, then what should be our answer? Then dp of I comma j should be equals to 1 plus dp of I minus 1 and j minus 1. Yeah, right. And if that's not the case, then dp of I and j will be equals to maximum of dp of I minus 1. I know we are missing some edge cases, we'll take care of them later. Okay, and here we'll return dp of n minus 1 and n minus 1. Now we just have to take care of the edge cases. Okay, so uh, we can just try it here. Uh, we can just initialize them initially, I guess. Like compare the zeroth element. Yeah, or if we can check that if these indexes are out of bounds. No, I guess that would be more beneficial. If if we initialize the first row, so which, so what if we initialize the our first row? So it would be dp of 0 comma j equals to if x1 of 0 equals to x2 of j. Similarly, what we could do is we can initialize first column here I, yeah, this should work, I guess. Oh no, we have to start from index 1. This should work. Nope. We got two cases correct. And okay, our output is 2 and it is expecting 3. Yes, this is correct, right? So we are initializing a first row, comparing it every this should work. Stupid minus G minus 1. Let's just test run it. dp of I will be a. So if we are at 0 index, then our loop will traverse from 0 to n, and dp of I comma 0 would be if those two elements are equal or not. Yeah, it should work, man. Have I written an index wrong? N comma n. Starting from the first row and from the first column. Oh, yeah. Here, if any of these is 1, yeah, so the problem is that, let's say, uh, we have found for first row, we have found two elements that are same. So for after that element also the answer should be 1, right? So we will maintain a variable bool p equals to false, right? And if this condition is satisfied, then b will be equals to true and this will be equals to b. Similarly, here also this is satisfied and b is equals to 2 and this will be true and false. Let's see if it works. It's giving up on last case. What's the problem? giving one. But these don't have anything common between them. The first row and this is the first row and this is the first column. Making me false. Oh, here it will be. Alright, I think our code should finally work. Yep. So we have solved this problem in both ways, bottom down approach and top down approach. I hope you guys like this video. I'll see you in the next one.